Hello YouTube, this is Eli the OBD Tech. This is part 4, this Evap Diagnosis. I finally got the new natural vacuum leak detector pump. I already have it installed, which is right here. And that's the old one right there, the defective one, which was stuck open. And the way to install this, this natural vacuum leak detector is to unscrew these two screws right here. They're either use a 10mm socket or a 10mm wrench. Take them off, and this shield should come off. And then to remove the switch, the pump, it has a little tab right here. Push down, and then twist to your left, and this pump should come out. As you can see, I have my voltmeter already set up. I already back probed the middle wire on the connector, which is our signal wire. So on this video, I'm going to show you guys how a good working natural vacuum leak detector pump should work. Like I said in part 3, that with the key off, engine off, the voltmeter should read approximately 5 volts. And if you pump 1 inch of a vacuum into the system, the switch should close, and the voltage should jump down to 0 volts. So, which means that the switch has gone into a closed position and has sealed the system. So right now, I have my voltmeter set up. So I'm going to take it to the engine bay and perform the 1 inch of vacuum into the system and make that 5 volts drop to 0 volts. Alright. I'm here at the voltmeter. Currently it's showing 5.45. That's with the key off, engine off. Now, if I turn the key on, engine off, this 5 volts should jump to approximately 10 volts. So I'm going to do that and then come back. So this is with the key on, engine off. The voltage went up to 9.83, which is approximately 10 volts. Now I'm going to go back and turn the key off, the engine off, and then perform this this vacuum test. So now I'm going to perform the vacuum test on the system by using my vacuum pump. I'm going to apply about an inch of vacuum, and this 5 volts reference should drop to 0. And here's what my vacuum pump already set up. I have it already hooked up to the bottom hose, which is your can side, to your evap canister. So I'm going to apply the vacuum and then watch the voltage drop to 0. There you go, guys. As you can see, the voltage has dropped to 0. This confirms that the valve has gone to a closed position, and this system is basically sealed off. And the next step is to have the car running, and this 0 volt should go to actually jump to 10 volts, which means that the valve has opened and the system is working properly. So I'm going to go ahead and do that and come back. So this is with the engine on, the voltage is still 0, and this 0 volts should jump to 10 volts. So let's watch it. It takes a couple minutes. So there you go. The voltage has gone to approximately 10 volts. We're now showing about 11.2. So right now the valve has opened. So this basically confirms that the system is working, and the problem was a faulty natural vacuum leak detector pump, which was stuck open. So this is how a good working natural vacuum leak detection pump should work. Alright. Hello YouTube, this is an extra clip to this part 4 video, Evap Diagnosis. I want to correct myself with the information I put out there in part 3 and 4, saying that the main cause of this NVLD pump being faulty was due to a stuck open switch. If that was true, we would have had a P0453 code, which I'm going to show you right now, which says that NVLD pressure switch stuck open. The second condition, if the PCM does not see the NVLD switch closed during test and error is detected, one trip fault. In which we did not have that code. We had a we had a P0440 and a pending code of P0441. Now, the main cause of this NVLD pump being faulty was due to a ruptured diaphragm seal, not holding vacuum pressure, which it did not allow the switch to close when when commanded. That's the reason that in part 3, when I applied the 1 inch of H2O vacuum pressure into the can hose, the 5 volts never dropped to 0 volts. So, in this video, I'm trying to correct that information I put out there. Now, I'm gonna take you to the P0440 and show you the information that the repair manual is showing. It's saying that on the second condition, it says that the PCM does not see the NVLD switch closed during the medium-large leak test. The PCM then will increase the vacuum supply to the Evap system by increasing the flow through the Evap purge valve. If the switch does not close with an increase in vacuum, an error is detected, 2-trip fault. And then the possible causes. Like the most the possible causes of of components will be the Evap purge solenoid, or the NVL switch operation, or maybe a bad ground, or a switch signal circuit open on the NVLD switch, or a evaporator emission system leak detection, or a PCM. But in part 1, I actually replaced the Evap purge solenoid, in which we had a P0440 and a P0456, a small leak. So the main cause of those two codes on part 1 was due to a faulty purge solenoid. Now on the P0441, in which we had as a pending, on the second condition, it says that the PCM activates the Evap purge solenoid, gradually increases to maximum flow. During flow, the PCM looks for the NVLD switch to close. If the PCM does not see the NVLD switch closed at maximum flow, and an error is detected, 2-trip fault. Possible causes as possible components is the NVLD switch operation, in which we already tested and condemned the NVLD switch operation being as the faulty problem. And then the other component is the Evap purge solenoid. But in part 1, we already tested that solenoid, and electronically it was good, but mechanically it was not holding vacuum anymore. So that so by replacing that purge solenoid, we got we actually fixed that P0456. So so this is just extra information that I wanted to put out there. So basically disregard my information where I said that the main cause was a stuck open switch. In this case, it was actually a ruptured diaphragm seal, not holding vacuum anymore. So thanks for watching. Subscribe if you like, and catch me on the next videos. Thank you.